Saxon Algebra 2, Lesson 91. Look, we're just sailing along through week 24. This is an interesting lesson. Relatively straightforward in terms of the calculations, maybe a little bit mind-bendy, okay? So let's start with something that we know. We're going to talk about linear inequalities. Okay, what do I mean by that? Well, let me draw a picture. All right, there's a Cartesian coordinate system, and I want you to draw just any kind of random line through here. I'll make mine go like this. Okay. We have done a lot of this graphing, right? And we know that lines have names, and we say y equals mx plus b. And we're not going to worry about specifics here, but we know that every line on this point, you could take the x value, you could plug it in and calculate it by actual numbers, not just letters, but you could actually calculate it and you would get a y value. And every single point on this line represents a pair of numbers, x and y, that will make this come true. That's all old news. That is all exactly true. However, what we've never talked about before is all of this space up here above our line. We can write an equation for this too. What we call this area is y is greater than mx plus b. Again, we're just using hypotheticals, but we could put in specific numbers for any of that. We've never talked about a greater than. And what about below the line? We can call these y is less than mx plus b. Oh, so there are names for the other regions of this graph besides just the line itself. And we call these areas linear inequalities because they're lines, but they have inequality signs in them, all right? That's that's the head bendy part that I'm talking about. We never really thought about that before, right? That we could name those other regions. And what we're going to do is, let me show you what it looks like. It's weird. I'm not going to pretend it's not. John asks us to graph the solution to this system of linear inequalities. He wants us to draw the picture of this region and then see where they overlap. Oh, well, that is just straight weird, isn't it? So let's do it. And I'll tell you what we do. The first thing that we do is we graph these as if they were lines with one special caveat. If it's just the inequality, like here, we're going to use a dashed line. If the equal sign is underneath, then we'll use a regular line. Okay? So we have to remember that in cases like this, we graph it exactly as if it were a line, but when we get ready to draw it, we're going to use dashes instead of a solid line. This lesson was really fun to teach on a whiteboard because I could just draw the line and then erase to make the little dashes. So let's do this. I'm going to do this one in red. Doing these in different colors is really helpful. Okay, we graph it as if it were a line. That means we start at the y-intercept. I'm going to mark all this because I didn't stay on the lines very well. again, if you're kind of particular about your graphing, please use graph paper. You'll be so much happier. If you don't mind winging it like me, just make them as neat as you can and don't worry about it. Okay, we're gonna go to +2. That's where we start graphing. And then we use the slope as a treasure map. We go up 1 and over 2. So this we see is where we're gonna draw the first line, but it does not include the equal sign. So we dash it. We can put arrows on that, okay? Now, that's only the first step. Now we have to shade the inequality. These are where words fail us. I'm gonna say region. When y is less than, we can see from this picture, that means below the line. Okay, we're gonna test this later, but generally speaking, if y is less than, then we shade the region below the line. So with my red pen, I'm gonna fill in like so, which means that this inequality can be solved by all of these points down here. Not the ones right on the line, but the ones that come up right next to the line. It's kind of the equivalent, you know how when we do just plain number line graphing, sometimes we circle the point and sometimes we color it in. This is like circling the point. We mean all the points right up to it, but not the points exactly on the line, right? It's this, not a combination of those. Okay, so all of these points should make this come true. And if we were concerned, we could test it right now, but I'm gonna wait and test it later. Now, let's graph the other inequality. We'll graph it as a line, but we'll adjust the designation appropriately. This has an equal sign, right? We pay close attention to the equal sign, if it's there or not. This one does have the equal sign, so I can go ahead and use the solid line when I get ready to graph it. Okay, fabulous. This is -3, so I go down here, 1, 2, 3. My slope, I can write in a 1 over a 1. It's minus, so that means I go down 1 and then over 1. Okay, so now, and I get to use a solid line on this. Ooh, that took a wobble, but you get the idea. Okay, I'm gonna write the names of them here. Y is greater than or equal to minus x minus 3. Now, this is greater than, so that means I get to go up from the line. From the blue line, right? Beautiful. And again, I'm using this information to help me shade the right region. I use a solid line because the equal sign is there. I go up from the line because when y is greater than, that means we go up from the line. This is super helpful in helping you know what to do down here. Now, what we're looking for, the system solution, is the area on the graph where we've got both shadings going on. So that's why I like to do different colors. It makes it a lot easier to see, but we can see that it's going to be above the blue line and below the red dotted line. See how I'm filling it in? So that it's easier to see, and I might even choose to do this. This is the solution to our system of inequalities. Okay? So our second step was to shade the inequality region. Then our third step, I'm going to go to the next page, is to shade the shared regions. And then we check our answer. With a test point. Okay, a test point is any point that we want to pick either in the shared solution or out of the shared solution, and we use it to verify that our shading is correct. The easiest test point to use is the origin, because multiplying by 0 is super easy. So what I like to do is I like to go back to my solution that I've proposed, and I look at where the origin is. If I'm right, and this heavily shaded blue area is the answer, then the origin should work as a good solution for both of these inequalities, right? Because the origin is in the middle of the shared solution. So it should be true for both of them. So I'm going to go ahead and I'm going to test both of these inequalities with the test point of 0, 0 and see if they come true. So I'm doing my test work over here. So the first inequality is y is less than, right? And so I plug zeros into this. 0 is less than, I don't even have to multiply that because I know it's 0 plus 2. That's the magic of using the test point. 0 is less than 2. Yeah, that's true. I don't even have to write it out the rest of the way. So the first part of my hypothesis has been confirmed because I thought that this point should work just fine for this first one because it is in the red region, right? If I look underneath. Now I need to see if it works for this one. It should work because it's in the shared region. So let's try the other one. Y is greater than or equal to minus x minus 3. Okay, I quickly plug that in. 0 is greater than or equal to, minus 0 is just 0, so I can write minus 3. That is also true. So our test point proved that our solution is accurate. So what our test shows all right, we expected that point to work for both of these. It did, so our test point has validated our solution, and our solution is right. I should write, when you solve these, I like to see the inequality written by the line part of it, just so that we're super clear that that line has a name, and that's what it is, right? So that's, I really like to see that on there. Okay, that is the first one. There's one more. Let's do it. I want to show you two though. In the book, here's how John shows the answer. Okay, we graphed that dotted line, we graphed that. Then we shaded all the region above this bottom line and below this top line. And then I used the extra blue lines to show this region. John doesn't show the other part. He doesn't show the individual regions. He only shows the shared solution. That frustrates me a little bit because it's harder for students to follow along with his thinking. But he goes right from here to here. I don't want you to do that. I want you to show the intermediate step of the other lines and then highlight the region in between, all right? So follow the way I did it. Let's do one more. We'll follow the same steps. Paper sticking, no news there. Example, this is 91.2. Okay. John does make these cute little inequalities. They're not particularly difficult. Remember that if we don't have a slope, we can always squeeze in our own. We'll have to do that here. This is a system. We're going to graph them as lines, although we'll remember that if they don't have the equal sign, like this one, we will use a dot, dot, dotty. I'll do this one in red. So let's see. I need some markers on here. We go to -2. Oh, it's right there. And then we go up 1 and over 1. Up 1 and over 1. There it is. This is a dashy dashy, not a solid. This is y is greater than x minus 2. And we know that when y is greater than, that means go up from the line. All right. Now we'll do the second one. Let's do green this time. And we'll do the same thing. We'll graph it this time. I see we'll be able to make a solid line. I want to circle this to remind us that we did the dashy on purpose. This time we'll do a solid line because we see the equal sign there. X plus 1. Okay, so we go to +1. There it is. And our slope is 1 over 1, so we go up 1 and over 1. Okay, now we can draw a solid line. The name of this line is y is less than or equal to x plus 1. When y is less than, that means we go down. And this is creating a very interesting solution. Again, this is the part that John does not show, the individual solutions. He just jumps right in and highlights the shared solution, which I go back in and use my individual solutions to find the shared solution. And look at what it's doing. It's running between these two lines, a dashy line on one end, a solid line on the other end, and it's staying like a bar between them. Why is it doing that? And we look and see, oh, it's because they have the same slope. It created parallel lines, one dashed, one solid. They are not the exact same line because they have different y-intercepts, but they have the same slope. So that means they're running along together. One is greater than, that's the red one going up. One is less than, that's the green one going down. So our shared solution is just this strip in between the two. That's kind of interesting, kind of fun, right? Let's do a test point and make sure that it's right. Again, I'm going to use for my test point 0, 0. And because my test point is inside the shared solution, then it should be true. I expect to see both true at the origin, right? So let's try it and see. 0 is greater than 0 minus 2. That is true. 0 is greater than -2. Now let's try the other one. Let me switch colors. That'll make it more clear. 0 is less than or equal to 0 plus 1. Also true. So our test results validate our graphing, so our test supports the solution. Okay? Now, the question remains, and this is the last thing I want to talk about. What if the origin was not inside the shared solution? In both of our examples, the origin fell inside the shared solution. What would we do if the shared solution was not over the top of the origin? Well, there's two things we could do. One thing we could do is pick a different test point that does lie in the shared solution, and that's probably the easiest way to get around it. Just pick a different point. But the other way to look at it is to say, what do I expect? So for example, let's say that this was our test point up here. We would expect this to test positive for the red inequality, but we would expect it to fail for the green inequality. That would verify our findings, right? As long as you know how this test point should work. It should work for the red one, see, because it's in among the red lines, but it should fail for the green one. If that's what you find here, the test still supports your solution. Even though one of your tests was a fail, it still supports that you've chosen the right regions to be your solution. So that's a little tricky though. That's a little complicated. I guess I would say the easiest way, the easiest way to sidestep all that drama I just mentioned is choose a test point that lies within your shared solution, okay? So it needs to be in here somewhere. If the origin fits, use it because the math is easy. But if the origin doesn't lie in your shared solution, just find another point that does. Right here I could choose 1, 1. That would be a nice point, right? Just choose something with nice numbers. That's lesson 91. I hope that makes you feel smart. Look at that. You look at that crazy picture and you understand what's going on. It's very impressive. Okay, thank you. Goodbye.